Hello, I'm Anna Mackay and this video is on discrete probability distributions and it's one of two videos. So let's start with this example where we have the number of tails obtained when two coins are tossed. So that's what capital X is representing. We need to draw a probability distribution table. As you get better at these, you'll be able to just draw them without thinking, but I'm going to show you through a tree diagram where the values come from. So again, in this topic, sometimes we talk about the idea of a success, and a success is the number of tails in this case. So there's two possible outcomes that could happen. We have a tail or a head. That's on the first coin toss. And then again for the second coin toss, we have a tail and a head, and a tail and a head down here. So looking at the outcomes, so where we follow along each branch, the top branch, you would get a tail and a tail. Here a tail and a head and a tail, and two heads. So when we come to draw our table, we always rule it up and we've got little x here and we have the probability of choosing one of those x's. And so what are they? It's the number of tails. So what are the different combinations that we could have? We could have 0 tails, 1 tail, or 2 tails. That's what we could get. And in these positions here, we need to put the probability of getting each of those scenarios. So the probability of 0 tails would come from this branch here. Two ways of working that out. You can see that there are 4 possible scenarios, and it's 1 out of 4 chances, or for more complex ones down the track where it's not going to be binomial, but in this case we've got a half chance of getting to that branch and a half of getting to there, so we would have a half times a half, and that would also give us a quarter. So that's another way of getting that. What about 1 tail? How many ways could we get that? Well, this option or this option. So that is, if you like, 2 out of the 4 options, which will simplify down to a half. So we'll put a half there as our probability, and getting 2 tails, again, 1 chance out of 4. So 1 over 4 goes here. So whenever you get asked to draw a probability distribution table, that's what you need to do. Let's look at some of the properties of these tables. Here's the official formula down here. So 2 things that make these types of scenarios true are that the probability of any one element in that table has to be between 0 and 1, because probabilities can't be greater than 1. The chance of getting 2 tails can't be 110%, for example, and likewise you can't have a negative chance of getting something. So that's what that means. This here, this is called summation notation, if you haven't come across it before. And essentially what it means is that all the probabilities of all the different outcomes have to add up to 1. And that makes something a discrete probability. So that's what we've got here. Each probability is less than 1. And if you add them all up, they will equal 1. So that's a key fact. 2 other things here, mode and median. So the mode, like normal, is the most frequently occurring value of the variable. So which one of these happens the most often? And as you can see, it's 1. So for this question here, we would have 1 tail. That's the mode, because you're most likely to get 1 tail. But what if you have to work out the median? Now, thinking back to what that means in other types of maths, it's the 50th percentile. So it's the value when the cumulative sum of the probabilities reach 0.5. So what do I mean by that? So I'll just work it out to the left here. Having a look at the first probability, it's 1 out of 4, which is 0.25. So we have to keep adding them up, now add that, until you get to 50% or 0.5. So then you look at the first one plus the second, and that's a quarter plus a half, and that's 0.75. So the moment you go over 0.5, then the one that you just added on, that is the median value. So the median number of tails here, just like the mode, would be 1 tail. So that's what you need to do for median. Here is a graph of what the distribution of that tossing 2 coins and working out how many tails would look like. The independent variable down here of the number of different tails that you can get, and graphing that up the side. So if you ever have to come and do a graph yourself, it looks something like this. Okay, another fact here, a uniform random variable. Think about what uniform means. If you're in a school with a uniform, everybody's wearing the same thing. So a uniform random variable means all of the different outcomes have the same probability, the same chance of happening. So hence that 0.25 here. Just looking at the numbers up here, that a note needs to be said that in any of the questions that you'll come across, these do not have to be consecutive. They do not have to start with 0. They do not have to be positive numbers, and nor do they have to be integers, hence the decimal numbers there. So when you come to draw up tables like this yourself, understand those facts, that all of these numbers are valid. Now, last thing here, if we have to find k in a probability distribution, how do we do that? Well, we need to use some of these facts here, that in total, first of all, each probability has to be between 0 and 1, hence the ones we've already got here, and adding them all up will equal 1. So let's use that fact. So we're going to add up each of these and put that equal to 1. So I'm going to just cut a step and go 2k plus k will give me 3k, and then if I add up the other two and put it all equal to 1, I'm going to get 3k plus 0.4 is equal to 1, and then you solve for k. So 3k is 0.6, leaving us with k is 0.2. So that's how you solve questions where you've got an unknown in the distribution. Okay, if you like this video, give it a thumbs up and subscribe to the channel, and the next video in this series will be part 2 of discrete probability distributions. Thank you.